So how does Angular know when one of our models is changed? Well, this is a fairly complex problem and it's something that every front-end framework has to deal with. And each framework has a different solution to this problem. In Angular, we use plain old JavaScript objects or POJOs for our models. And these models don't have a set method that we can call to update them. Some frameworks provide an API like that, so you call the set method and that would internally tell the framework that something has changed. But in Angular, we don't have that. We use plain old JavaScript objects. So Angular needs to run its change detection in the background at specific points where the model state can change. But what are these points? Well, model state can change as a result of three things: DOM events, like click, key up, and so on, AJAX requests, and timers. So Angular needs to perform its change detection right after any of these entry points. But how can Angular know when a button is clicked or a key is pressed? Well, in Dart programming language, we have a concept called zone, which is basically an execution context for running asynchronous JavaScript code. When we execute an asynchronous function in a zone, we can run some code before and or after that function. Now, back in our list, all these operations here are asynchronous. So if we monkey patch or modify these operations in the browser and run them in a zone, we can run some code right after them. And this is the perfect opportunity to perform change detection. But we don't have this concept of zones in JavaScript. Well, Angular team have actually implemented this concept in JavaScript, and it's available in a library called zone.js, which is one of the dependencies of every Angular project. So Angular monkey patches these entry points and runs them in a zone to trigger change detection. Okay, so now you know when change detection happens. But how is Angular going to detect these changes? Well, every Angular app is a tree of components. At runtime, Angular creates a change detector class for every component in this tree. So just like we have a tree of components, we have a tree of change detectors. Each change detector is created based on the data structure of the component that it targets. So the change detector for app component is different from the change detector for movie component. And this is for performance optimization. This way, a change detector can perform several thousand checks in just a few milliseconds. So it's not like we have a generic change detector that takes care of change detection of every individual component. So when change detection runs, Angular walks down this tree of change detectors from top to bottom. It asks every change detector, hey, is there a change? The change detector can say yes or no, because it knows the structure of the component it's targeting, it knows the previous state of that component and its current state. So if there is a change, Angular instructs the corresponding component to re-render and update the DOM accordingly. So this is how change detection happens. Next, we're going to see this in action.